the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to our second lesson in Unit 4. In our last lesson, we learned that a chemical reaction is a process in which reactants change into something new called a product. We learned that a chemical reaction can be either spontaneous or non-spontaneous. A spontaneous chemical reaction requires no input of energy, while non-spontaneous reactions usually need the input of energy, such as heat, light, or electricity. We also discussed the 3 changes that indicate a chemical reaction has taken place. These include a change in composition, a change in properties, and a change in energy. Not everything changes during a chemical reaction, though. Today, we will focus on the law of conservation of mass, also known as the law of indestructibility of matter. It tells us that matter can neither be created nor destroyed. The mass of a closed system will remain the same over time. We can think of the law of conservation of mass as an idea that came from Greek philosophy. Nothing comes from nothing. Therefore, everything that exists now always existed. And everything that exists now will always exist. French chemist Antoine Lavoisier discovered the law of conservation of mass in 1774. During an experiment, Lavoisier heated a sealed glass container that had a piece of tin and some air inside. At the end of the experiment, Lavoisier found that the mass of the reactants before the chemical reaction was the same as the mass of the product it created. Let us look at an example. If we mix sodium chloride and silver nitrate together, we create a silver chloride precipitate, which is a solid within a solution. Even though a chemical reaction has taken place, which caused the reactants to form a new product, the mass of the product remains exactly the same. Let us look at an experiment to show this.
For this synthesis you will need silver nitrate and sodium chloride, which is table salt. Here is the silver nitrate. Make an aqueous solution of silver nitrate by dissolving 2 spoons of silver nitrate into 50 milliliters of water. Just do the same with the sodium chloride. I used about 3 spoons. Add into the silver nitrate solution the sodium chloride solution. When you are adding the sodium chloride solution, you will see white clouds appear. This is the silver chloride.
If we compare the mass of M1 to that of M2, we will find they are the same. Thus, the mass before the chemical reaction is the same as the mass after the reaction. Students, consider injera and how it is made. Write down the ingredients or reactants. Then think about whether or not the mass of these reactants is the same as the mass of the final product, the cooked injera.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to think of all the ingredients needed to make injera? I am getting hungry just thinking about it. Let us watch. You probably mentioned teff, flour, water, and irsho as the ingredients for making injera. You were right to say that the mass of the ingredients used to bake injera is the same as the mass of the finished injera. Therefore, cooking injera follows the law of conservation of mass, just like all other chemical reactions. During a chemical reaction, no substances are lost or gained, so the mass stays the same, always. Though sometimes it can seem as though this is not the case. The breakdown of mercury oxide is a good example. When heat is added to 100 grams of mercury oxide, 92.6 grams of mercury is formed. It seems as though the mass has decreased, but not so. If we weigh, 100 grams still exist because 7.4 grams of oxygen was also created during the breakdown. Teacher, please arrange the students into groups of 4 or 5. Students, as a group, think of a chemical reaction where the mass of the reactants seems to differ from the mass of the product. Then, please write down your ideas for where you think that extra mass went.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. How did you do? You might have thought of a log being burnt. It seems as though the mass of the log is disappearing as the log burns. However, as the wood burns, it not only turns into ash, but it also turns into gases and particles. You might have also thought of a plant decaying. It seems as though the plant just rots and disappears. However, the plant particles break down and become a new organic product, soil. One more reaction you might have thought of is food being digested. It seems as though the food we eat disappears after we eat it. However, the food is broken into smaller bits and sent throughout the body wherever it is needed. This exercise was meant to help you understand the law of conservation of mass beyond what you can see and feel. Today, you have learned what the conservation of mass is, and have seen examples of it within chemical reactions. You have also learned how Antoine Lavoisier, who is considered to be the founder of modern chemistry, discovered the law. This concludes today's lesson. Until next time, thank you, teacher. Thank you, students.